Hi, everyone. Welcome. This is Naturally Speaking, Cabrillo National Monument's free science talk. We're going to get started here in just a few minutes, probably about 2 to 3 minutes past the hour to give folks a little bit of time to trickle in after work. So go ahead and grab some water, maybe a cup of tea, get cozy, and we'll get started here in just a minute. Hi, folks. Welcome to Naturally Speaking. We are giving folks a couple of minutes here to trickle in. So go ahead and get comfortable, and we'll get started in 1 to 2 minutes. All right, everyone. Welcome to tonight's installment of Naturally Speaking. We're going to go ahead and get started because I know our guest speaker tonight, Dr. Keith Lombardo, has a lot of really interesting things to cover. I'm your host, Sam Wins, scientist and science communicator at Cabrillo National Monument. And before we get started, there's just a couple of very small housekeeping items here. This isn't a webinar format. And so you're only going to be able to see the host. You won't be able to see anyone else on your screen here. So don't panic. That's natural. To ask questions, we ask that you use the Q&A function. The Q&A function is a really great function that will queue up your questions so that we can queue them up to the very end when Keith will be answering them. Um, he might periodically stop to answer, but I think we're going to wait to the very end. Um, you can use the chat function to answer any questions that Keith might ask of you, or to say hi to anyone else you'd like to as well. Please keep your mic muted. There's a lot of us, and it can get a little chaotic if people are unmuting. And captions should be available by clicking the closed caption icon that'll either be at the top of your screen or at the bottom of your screen, depending on what version of Zoom you have. All right, and without further ado, I'm going to introduce our speaker. Let me stop my share here. All right, excellent. Um, so Dr. Keith Lombardo used to be my boss at Cabrillo National Monument. He used to be the chief of resources management and science at Cabrillo. And then he went on to become the director of the Southern California Research Learning Center, which I know he's going to get to what that is here in just a moment. So without further ado, I'm going to pass it over to you, to Keith.
Thanks, Sam. Hello, everybody. Thanks for showing up after work to hear a little bit about our science in Southern California and our national parks. So make sure everyone can see the screen. Yeah, Sam, it's on your screen. All right. All right, so away we go. Uh, Hiccup number one. It won't let me progress my slide. There we go. Okay, so just to give you a little background of where we're going to go tonight, right? So the outline of the talk, a little bit about who I am, my academic background, professional experience, talk about the mission of the Park Service as it relates to my position, and a little bit about what research learning centers are and the objectives. So that's going to be pretty quick, as I think some of you have seen a version of this talk, and already know me, probably knew a lot of this. So we won't go too much into depth there. Where the meat of this talk will be is science in the three Southern California national parks, Channel Islands National Park, Santa Monica Mountains National Recreation Area, and Cabrillo National Monument. So a little bit about who I am. So my background, I have a PhD from the University of Arizona, where I studied dendrochronology and fire ecology in particular in Southern California. So there's a lot of really cool tree work that involved, reconstructing 700 years of fire history in Southern California. And so there's a lot of fire ecology, plant ecology work. I was really fortunate out of graduate school to get a full-time permanent position with the Park Service at Cabrillo National Monument. I tell people that's akin to winning the lotto. It just doesn't work that way. That's a whole nother talk. But yeah, I was really, really happy to accept the position and move to San Diego. I mean, who doesn't want to live in San Diego, right? And so there I worked on plant monitoring and restoration. And I was really fortunate to be able to kind of move up the ladder at Cabrillo and assume the position of what was then called the Chief of Natural Resources at Cabrillo. And that was oversight of all the monitoring programs at the park, both terrestrial and marine. And then about 5, almost 6 years ago now, I accepted this position as director of the Southern California Research Learning Center. And you can see my focus and interests now are pretty varied, right? I've become sort of an intertidal ecologist by default. I like to say I played one on TV, but I'm not really an intertidal ecologist, but I like to pretend I am. Cross-border science, data science, conservation genetics, climate change, and coastal systems. So yeah, really kind of varied interests now. And I'm just going to read to you the mission of the National Park Service. And I'm sure many of you have heard this before, right? But I was going to read it and I want to emphasize a couple things. The National Park Service preserves unimpaired the natural and cultural resources and values of the national park system for the enjoyment, education, inspiration of this and future generations. Right. And you can see what I've bolded here, right? Preserves unimpaired. So they're supposed to be, these perfect ecosystems, with no, impairment, right? And for the enjoyment, so that our visitors can come and enjoy these parks and visit them and learn more about their natural systems. And we're supposed to do it for this generation and forever, right? So you put all those things together, it's a huge mission. And understanding the science behind our resources is a part of that mission, right? And I wouldn't say a small part, it's a pretty large part of our mission. But again, a really big task. And so how does all of this relate, right? So you hear the mission of the Park Service. Now we're going to get down into the weeds a little bit into like what science and resource managers do. So you can see here these three areas: resource management, inventory and monitoring, and science, right? And I like to call this like the stool, the three-legged stool of how we manage their natural resources. So up top you have resource managers, right? And that's folks like Lauren Pandori, and other folks across the Park Service whose day-to-day responsibility is to ensure that these our resources are cared for and that we're making the right decisions so that they are unimpaired and they stay unimpaired, right? And how do we fix those that are impaired to make them more as they should be? And then we have another group called inventory and monitoring. And those are really the scientists and the biologists who are out in the field every day, counting things, assessing change, collecting all the data, right? As to how these things are doing. Because that's how we understand how things are going, is by collecting data and then looking at that data over a long period of time. And then there's science, right? And science is more of that question-based, like, oh, okay, we see owl limpets are declining, but why, right? And that why is sort of the scientific question. And what I really focus on in my role is the science aspect, right? And it's not so much that I'm doing all the science, that I'm analyzing this data and writing all these papers, right? It's more that I'm helping facilitate the flow of this information between all these folks and different bins that help manage the natural resources of the National Park Service. So again, so I still do a little bit of science, but really my job is to facilitate science across these parks and within these parks and these areas. And so that's really what research learning centers are designed to do, right? So facilitate science in the parks. And I'd go into more details. It's actually kind of interesting, but I don't have that much time. There are 18 RLCs across the country. and they're all a little bit different. It's sort of organic. They allow them to be organic. So some focus on science education, others on just pure science and so forth. So they're all a little different. But what we have in common is we have these four goals. And I'm going to read them to you, right? So the first is promote national parks as a premier place for scientific inquiry. And so this is really like me going out to academic institutions or research partners and saying, we've got this great natural laboratory and we've got all this long-term data. You really should be coming to our park and exploring more and conducting your science in our park. That's a part of our mission, right? Is to be this natural laboratory for you, the inquisitive scientific public. The second is to facilitate and promote the use of science to make resource management decisions. And I see one and two is very similar. They're just kind of two sides of the same coin, right? This is more like when Lauren might have a question about what's going on at Cabrillo, and she's got this data showing a trend, but we don't really know why it's trending in this direction. And we don't maybe have the in-house expertise to answer that question. So that my job is to find scientists who might want to collaborate with us to help us answer that question. Number three is to improve science literacy by incorporating science into the visitor and staff experiences, right? So this is science communication and outreach. An example is this talk right here, right? Talking to you, the public who want to learn more about their parks. But it's also, we want people who are in a park just maybe they're just there for the view. Maybe they're just there because someone told them it was a cool place. We want them to walk away thinking like, oh, there's science conducted in these parks and it's an important part of the park. And we also want our staff to understand that as well. A lot of times if you go to the park, the person you see is you might see an interpretive ranger, but you might see a facilities person, a law enforcement ranger, right? And a lot of times they'll get questions like, hey, what's that guy in the orange vest doing? Hey, why is that bee here? What's this and that, right? And we want them to have some idea of like the science and the important issues in the park. So it's important that we educate our staff as well. And then lastly is to assess and evaluate RLC activities and adapt as necessary to achieve the vision. And for me, this is like a self-reflective goal. Like, am I achieving my mission? And really, I think the value in this for me is to be able to pivot quickly, right? We all know the government is slow and bureaucratic and it takes forever, right? You have this issue that pops up and they say, that's great, we'll fund it in 3 years, right? And that's not enough time. I'm very fortunate to be able to pivot really quickly year to year and address our emerging needs. So I use this as a opportunity to look at how my program is doing and are my partners and colleagues happy, and also to move quickly to address issues that are emerging. So a little spatial context. So what are we talking about? Again, so here's Cabrillo National Monument in San Diego, where we are today. And then there's Santa Monica Mountains National Recreation Area, just north and west of the city of Los Angeles. And then the Channel Islands, which are headquartered in Ventura, but it's 5 islands off the coast. You can see the big yellow blob there. Those are the four northernmost islands. And there's little bitty Santa Barbara Island down here to the south. And so without further ado, we're going to dive into the cool science, and I like to call 3 parks, 3 stories. But in the spirit of Black Friday and Cyber Monday and Giving Tuesday, it's a limited offer. I'm giving you 6 stories of hope for the price of 3. So it's your lucky day. You'll get 6 stories today. And before I go any farther, I want to acknowledge Michael Reedy, who's a photographer and a naturalist I work with. All of these beautiful pictures here are all of Mike. He's a really close colleague of the park, and he's done a lot of great work. And so I really believe that, you'd much rather see these beautiful pictures than a bunch of text and have me read it. And it's a really effective communication tool. And these are just really beautiful to look at, right? And so any really beautiful pictures, Mike. This picture of Mike is grainy. That's me from my iPhone. So a grainy, ugly photo, yeah, that's probably credit to me. Everything that's beautiful, you can just credit to Mike. So let's start at the Channel Islands, where there's lots of really interesting things going on. Incredible terrestrial and marine resources. It's a really big park. It's really remote. It's really challenging to work there, but there's so much important work that goes on at the Channel Islands. And again, so you can see here, just to give you the context, right, the 4 northern islands here, Anacapa Island, then Santa Cruz, Santa Rosa, San Miguel. Those are the 4 northernmost islands. And then Santa Barbara Island is the southern and 5th island. And you can see the other islands out here, San Nicolas, San Clemente, and Catalina. And the first project and the first story of hope I'm going to tell you about is the binational brown pelican monitoring project. So brown pelicans, right? If you've been at Cabrillo, you've seen a brown pelican. They're always flying back and forth along the coastline. They fly in that lovely V formation and skim the waves. I always think the wave is going to take them out. They never, ever, ever get hit by a wave. It's really amazing. And so a little bit about or where these birds come from. Historically, they were mostly found in the Gulf of California. And you can see on this graph here, this is from 2017, 61% of the population basically was in the Gulf of California. Like another 20% were other parts of Mexico. And then a little less than 20% were in the Southern California area, right? So 80% of these birds live south of the border and mostly in the Gulf of California. But there's been big changes happening, right? And this kind of simple graph here, this is the number of pelican nests in the Gulf of California. And you don't really have to look at the data too much just to see like there's a huge decline, right? From 20,000 nests down to 5,000 nests over this period. It really started to happen in like the early 2000s, and it started to accelerate, right? So the population is shifting out of that area drastically. And where are they going? Right, so these are nest attempts on Anacapa and Santa Barbara Island, two of the Channel Islands, right? And you can see the blue is Anacapa and the red is Santa Barbara. And you can see some pulses here, right? They come and go a little bit, but look at like 2014 on, there's just a lot of nests, a lot of nesting attempts and a lot of successful nests too, right? So they're moving out of the Gulf of California and coming to the Channel Islands. And what's driving that change, right? That's the big question, right? And that's that sort of science. Why? We can document this happening, but why is it happening? Well, what we think is happening is two things really, and the two things are related to each other. One is you can see here on the graph on the left, anchovy spawning stock biomass in Southern California. That's the number of anchovies just being caught, right? That's just a reflection of how many anchovies are in the area, and that's drastically increasing over time. And what's happening is the anchovy are moving north. The anchovy are very common in southern in Baja California, and now they're moving north. And why are they moving north? Well, warm waters, right? They like kind of cooler waters, as the Gulf of California has really heated up in the past 20 years. And, everything's kind of shifting out of there, trying to find those cooler waters again. So everything has shifted north. And so the anchovy are moving with the water, right? Finding cooler water. And if the anchovy, which are something that pelicans love to eat, are moving north, pelicans are going to move north, right? And so, this is kind of important information, right? They're declining, so we have these concerns, but they're increasing elsewhere, right? And the big question is why, right? And so we think that that is the case. And so, um, that the islands themselves are providing this refuge, which is really an important point, right? We're protecting these islands for a lot of reasons, but they're refuge to species that we didn't even think about in the past when these were made a national park. They weren't thinking like, oh, this could potentially save brown pelicans, right? And the brown pelicans were once on the endangered species list and have recovered. But in this new world, right? What if the Channel Islands weren't there? Where would they go? They might be able to follow anchovy, but they'll have no really place to nest and to reproduce. And so what this project has done is the Park Service is working with a wide variety of agencies who kind of monitor seabirds. And what we are starting to do is fund folks in Baja to start banning those birds that are remaining in southern in the Gulf of California, and then tracking them, right? So they get banded as fledglings in the Gulf of California, and then they migrate and they go places, right? And some stay, and we know that, but then others leave. And there's a really cool system called MODIS, right? It's these kind of antennae systems, right? That have a capacity to pick up frequencies, and these birds are banded with bands that emit a frequency. And the MODIS stations are all up and down the coast, so you can like if this bird on the left here had a band and it would pass these stations, it would pick up that bird, and we could say, oh, bird 871B is moving north, and we have it all the way in San Pedro now or something like that. And so now we can figure out. So we think birds are moving from the Gulf of California to the Channel Islands, but now we know which birds and how many birds are actually making those moves. And so this was a project I helped fund with the park, and with a lot of other funders and collaborators as well. It's a very big project. So for me, the conclusion here is like it's islands of hope, right? It's these islands are so important and beautiful and amazing, but here they are as like a refuge for species that are on the move, and it's sort of almost it's a great story because most of our climate change stories are ones of misery, right? And are have a bad ending. But right now, we think like, wow, Channel Islands are playing a huge role in potentially saving a species in an era of climate change. All right, let's move on to our second story. This is not an alien from a Hollywood studio, although it looks like one, right? This is a really weird looking animal, but this is a black abalone. And it's a lot of these images come from a new story map that Michael Reedy and my other colleague Alex Warnicki have put together. I'll share the link in the chat at the end of this talk here. I encourage you to go look at it. We've put a lot of story maps out, but in my opinion, this is the best story map we've ever created. So I'll share that with you, and you can go into more depth about black abalone and see some more really amazing photos from Michael. So a little bit about black abalone. You see them here on the right in this image. These are big mollusks. They're, about the size of my hand when they're adults. And on the left here, you see the historic range. So, even 100, 200 years ago, you would find abalone all the way from the southern Oregon coast, all the way down to the southern tip of Baja California. And anywhere you had rocky intertile, you would have black abalone, and you would have a ton of them, like literally stacks of stacks of stacks of black abalone. The estimate is something like, and I think this is like they're undershooting it, like tens of millions of black abalone across this range at any one time. And that's probably an underestimate. There was probably, you know, 50 to 100 million abalone at any one time, right? And so they were everywhere, and they were the dominating species in the intertidal. They were a foundational species. But now look at the current range and compare them, right? The northernmost area we find them is just north of San Francisco, like Point Reyes area. And then down to central Baja California, we can find them. But this is even deceiving, right? That's a pretty sizable contraction in the range. But what you don't find is is those numbers of black abalone in the mainland. You'd be lucky to find, a few hundred across like a good chunk of the California mainland, right? They're just not there anymore. They're really on the islands, which are a little more protected and a little cooler. And then this is just a graph from one of the plots in Channel Islands, just to kind of show you the trend that's occurred. And this is across the range, across, all kinds of monitoring programs. You see this, right? You see, black abalone going from this really high dense number in the 90s down to almost nothing in the 2000s, and then a kind of continual decline into, the common day. So they're really, really limited in numbers now, and they're an endangered species. And so why is that? And there's two reasons. One, and that kind of set the stage, is overharvesting. You can see a couple of images here from like the early 1900s. And at the time, people are looking to establish industry and find food to eat, right? They're also edible, and many people find them delicious. And you see a couple million of them out there, and you can eat them, and you can make money off it. The thought is like, wow, man, there's millions of them. We can't possibly put a dent in that population, right? Well, turns out we can, right? We put a pretty good dent in the population, but they were still healthy. They would still be there, right? And when they're around, they reproduce abundantly, so they can recover. But we reduced it to such a low level that we put them in danger of just getting kind of knocked down to or decimated to a level where they can't recover if some natural event occurred, which did, right? So withering foot syndrome came through. It's a disease that's common. It's been around for a very long time. There's some samples of abalone from like the 1800s, late 1800s, and the disease is present. But there were so many of them, and the disease was so limited that it didn't impact their population. But once you shrink that population to a number that becomes a really almost barely sustainable population, and then you introduce this disease, which became more widespread as the water warmed up, right? Now you put the population under real pressure, and it got to the point where black abalone were just, really decimated. You'd be lucky to find 10 or 15 on one of the Channel Islands, right? So very, very few black abalone were left. But, and the message is story of hope, right? And so here's another story of hope. On the left or the right-hand side, you can see a graph from the Channel Islands, and you can just see the general trend of all these different islands and sites. is upward trend, more and more abalone every year. And then on the left, you can see these are photos that Mike took on our very recent trip to Santa Cruz Island. And you can see, like, we found so many little crevices where this is what abalone should look like, right? So many they start to stack on top of each other, right? And that's really important for their breeding. They need to be like really dense and clustered. And so at this one site, we found 3,000 abalone within like a 15 or 20-minute search. So they're really recovering. And we think, right, the science, this is the why. Why are they recovering, right? We know they're doing better. We don't quite have the answers yet, but we think that the water has been warmer or cooler the past few years, so they may be recovered because the disease doesn't do so well in cold water, right? We think that's a possibility. But if the water's warm, maybe it comes back and the population has declined. We don't know. But we just think that they're just potentially there's a disease resistant population forming, and what we're finding is that in the subtidal areas, the populations are even more abundant. So potentially those that were in colder water, not exposed to the disease as much, has developed some sort of resistance, and they're starting to spread from subtidal to intertidal. So it's hopeful, right, that they're recovering at least on the islands. And they're recovering so much that a group has decided, like, why don't we take a few from the islands, which there are plenty now, and transplant them to the mainland to see if we can establish a new mainland population. So this was a group of California Fish and Wildlife, NOAA, and U.S. Fish and Wildlife Park Service, Nature Conservancy, a couple of universities, a really huge effort to take 100 abalone from Santa Cruz Island and move them to the Nature Conservancy Dangerman Reserve. See just north there, right near Point Conception. And so here's the adventure, right? It was a true adventure. Here's us on the boat, right, heading out to the Catalina to Santa Cruz Island to collect abalone. Here's us digging in holes, right, trying to find these guys in these crevices, securing them, taking all kinds of data, and then transporting them from the island to the mainland and then out into the mainland habitat. And you see this bottom right-hand corner, find these little crevices and nooks and crannies where you can kind of stuff these guys, right? And the good news is that greater than 75 of them are still around after a year. And even better than that is that we didn't find any empty shells, which means that there's probably 25 more, right? They move around so that they're just not where we can see them. But we think we haven't found any shells. So we think close to 100 are still alive. So we're so encouraged by that. Now that we're taking another 100 and adding another 100 to that population in hopes of like so every year maybe do this and you create this big cluster is once they get their numbers up, then they can start breeding on their own and really populate the area. So again, a story of hope. And the hope is, right, that we just start seeing more and more of these sort of situations where we have just more and more abalone covering the intertidal. Okay, let's move on to the mainland and talk about a couple stories in the Santa Monica Mountains. And here's the park here is this big chunk of land just north and west of Los Angeles. And one of the things I really love about Santa Monica Mountains is it's the most crazy juxtaposition of wild landscape with major urban area. Like this photo on the left here, right? You're in, look at there's a trail and then there's a whole bunch of open that's natural chaparral, perfect habitat. And there's a city, 20 million people right next to it, right? It's just a crazy juxtaposition. But with that and within the park, right, are things we love, which are roads and cars, lots of roads, lots of cars, right? And so that has a lot of effects, a lot of fragmentation of the landscape, and it has a huge impact on the wildlife in particular in the park. And especially these guys, right? This is sort of everyone kind of knows the story of mountain lions and Santa Monica Mountains. And they're really impacted by the fragmentation of that landscape. And you can see, just all these major roads, right? Here's the 405 and the 5 and the 101. And the 405 and 101 really kind of hem in the Santa Monica Mountains, right? And then the 23 and the 118 just north of it also sort of kind of pin everything in. So moving across that landscape is quite difficult for an animal that needs, a huge amount of area to be successful. And just to give you an example of like the issues we see and to give you a kind of a visual, right? these blobs are basically the home ranges of particular lions that we followed through, GPS collars, and you can see, right, they're all pinned into the Santa Monica Mountains in the south and the Simi Hills to the north, and they're overlapping each other, which they don't want to do, right? And you have some that are pinned into really small areas. So you're really isolated from each other. And that's not good because then they're going to inbreed, right? There's no genetic flow between these populations, and then the males end up killing all the babies because they feel threatened, right? So it's just not a sustainable way for a large mammal to exist. So that's why so much effort and money is being put into this, which you may have heard of, the Wallace-Annenberg Wildlife Crossing. So this is it's the largest wildlife overpass ever built in the U.S. It's going to go over the 101, right? So over, I think this is like 8 lanes of highway or 6 lanes on both sides, something crazy like that. And we're really hopeful that this is going to be like one piece of the puzzle that we need plugged in to create a better space for these lions. And so again, so here's this map again, right? You see the Santa Monica Mountains, which has a pretty large population of lions. I think there's 20 or so that kind of come and go. You have the Simi Hills just north of it, there's a lot of open space there. The Santa Susana Mountains are even more open space. But then the mother lode of open space is the Los Padres National Forest, which is 2 million acres of wilderness, right? And so there are a lot of lions in there. And what we would love is for our lions in the Santa Monica Mountains to eventually make it to the Los Padres and vice versa, right? And so that would allow for a really robust flow of genes across this landscape, and we think it could save the lions. And so you can see these little red hashes here. The first little red hash above Santa Monica Mountains, that's exactly where the overpass is being built now, connecting like two of the areas where we still have open space on either side of the 101. But you see the two other red hashes that I've added, and that's where we need more overpasses, right? Because it's great we can get them to the Simi Hills, but we still have like a couple major roads for them to cross to get to the Los Padres. So this is great that we're taking step one, but we need step two and three to really see this project through. And the good news is there's funding for step two, which is a huge issue. It's a lot of money, hundreds of millions of dollars for each bridge, but the funds are there. So very exciting. And I think there's a lot of good momentum now. I wouldn't be surprised if the third one gets built as well. So very hopeful for our Lions. And so again, right, so this is all in the context of mountain lions, and it's because they're the apex predator. They're super photogenic, right? Everyone loves a big cuddly kitten like this. But there's so many other animals that are going to benefit from this. Coyotes, black bears, and bobcats will all use this bridge. We're even like looking at the genetics of quail because we think quail are going to use this bridge, right? So it opens up the ability for so many other species to, expand their range and have a better flow of genetics than what we have now. And so a little bit about the bridge, right? These are a couple of images from the summer. The bridge is 210 feet in length and 174 feet wide. And you can see in the bottom right, here's where they put on the first girders. There are like 83 of these massive steel girders that make up the bridge. And then the upper left-hand corner image, that's from August of 2024. And you can see all the girders are in place and that the main part of the bridge is built. The big things that are left you can see it still needs to be connected to the surrounding landscape. And then there's actually a second smaller bridge that's being built on the south side of that overpass. So there's actually another frontage road that they have to also build a bridge over. But the estimate is early 2026, the bridge will be complete. And so it's a bridge, right? But it's not laned with, asphalt and for cars and people, right? It's going to be vegetated. It's essentially like, we're actually building a tunnel through the earth rather than building a bridge for cars to go over. And so with that comes another huge project of how do you vegetate something this big, right? There's 5,000 plants alone just going on the bridge. It's a lot of plants, right? And then 25,000 plants that are going to go around either side of the bridge. That's a real lot of plants. So that's a huge effort, and Samo is undertaking the whole thing themselves. And they have this massive, incredible nursery that puts out 60,000 plants a year, which is a huge number of plants, right? And so every year they're churning out 60,000 plants and planting them. And then at some point, half of those are going to go towards the bridge. And that alone is a massive effort, right? Just to grow that many plants from native stock and native seed. And what they've been doing is just massive seed collection efforts, right? Because they need to grow out a lot of plants. So they go out and they collect all these seeds, label what species they are, where they came from, and they store them, in a climate controlled area, right? You can see all these seeds in their envelopes in the refrigerator, but they're also creating these essentially a document, a pressing of each plant so that they know like, okay, so is in 100 years, people might say like, well, where do they get the plants to plant on this bridge? And it's really important that the plants they're using come from the park, are native to the park, and the genetics are local to the park, which just give them the best chance to survive, right? If the plants are grown from native stock in the park. So they want to document that, right? And so they have a press of each species, where it was collected from, what the taxonomic information is at the time, and then these hard copies, you can actually get genetic material. So if in 20 years someone needs to test something, you can scrape off a little flower or a leaf from one of those plants, get some genetic material, and test it. Right, but that's a lot of work, and like this huge cabinet, right, of plants, and that's just like a fraction of what they have. So they were creating this massive catalog of plant pressings. But in 2018, the fire burnt down the repository, and they lost thousands upon thousands of these, some from like, dating over 100 years back. So it was a huge loss. It was a substantial loss for the park and the resources. And so they're going back, redoing everything, right? With, going making new pressings. And so that's important, right? We'll keep doing that. The genetic material is really important to have that. But they're also doing something else, which I think is really smart, is creating a digital herbarium. So, right, they create the pressing, and then they put the pressing in this light box. You can see on the left here, it's this light box, and it's a high-res camera mounted on top. And they snap a photo of that plant, and it creates a digital file. So you get it's so high resolution. It's almost as good as looking at it in your hand. The only thing you don't get access to genetic material, but you get everything else. So it's a really great safeguard. Against loss in the future. So again, stories of hope, right? So we're hopeful now we'll never lose these plants again. And all of these will be uploaded into the California Conservation or Consortium of California Herbarium, which is a digital herbarium across California, which you contribute your samples to, and then anybody has access to these, and researchers can use them for a variety of projects. All right, so that was my 4 stories of hope, and now we have 2 left from our favorite park, Cabrillo National Monument. So I probably don't have to tell you and sing all the praises of Cabrillo to this group, right? You're here because you love the park, but I just like to tell people like look at like it has tremendous natural resources, both terrestrial, marine. The setting is incredibly unique, a peninsula and overlooking the city of San Diego. It's a wonderful place to visit, but it's a great place for science because it's so small and compact and has so many cool coastal resources. You can study so many interesting things. And one of the things I always has been fascinated about the park is fog, right? If you've been to Cabrillo at some point, you've probably run into the fog banks that roll up the hills, right? And it's common across Southern California. Here's some fog sitting on Santa Cruz Island. Like fog plays a huge role in Southern California. We know that, or we think that, but we don't know it, right? We don't know what the actual input of fog is. Like, how much fog do we get? And like, how important is it? How much does it translate, from fog to water? And do plants use it, right? It's a huge question that very few people have kind of dug into, which is surprising, right? And so I'm really proud of our parks for trying to start to document how much fog we're getting. There's several ways to do this, but this is one of the most unique and I think novel and probably most technologically advanced way to do it. And it's something that Lauren and her predecessor, Lenan, were really big supporters of, is creating these fog stations, right? So the setup here is a typical weather station, right? So it's collecting your normal weather data. It's solar powered, which is great. And then you've got this little compartment where you keep your batteries and your loggers and all the kind of the guts of the system. And then it has these sensors that run out, and they're called leaf wetness sensors. And I'm not doing it justice, in this description, but essentially, right, there are little sensors that mimic a leaf. And when moisture falls on that sensor, it converts it, it records it as electricity, and then but there's a way to sort of say, okay, if you're getting this much electricity, you're getting this much water. And so there's a way to sort of say like X when we have fog, this is the amount of moisture a plant is actually feeling on a leaf, right? And so that's a really good way to sort of understand like how are plants actually using fog and taking fog in. And so the park was really clever, not just putting one up, but putting four, right? And they're arranged in a very interesting way and a very clever way. So you can see down here by the tide pool entrance, right? They have the oceanside one, which is about 15 meters above sea level, right? So that's the lowest elevation immediate to the coast, right? Then they have one that's upslope a little bit, right? It's 50 meters above the ocean, but still, prominently on that west coast side where it's going to get a lot of marine influence. There's one high up on the ridge line, kind of right by the wedding bluff, and that's right on the ridge line, 120 meters above sea level, but still prominently facing west. It's going to get a lot of that moisture from the ocean again. And then there's one on the bay side, so much drier, right? So there's a good comparison to see like, well, does it wrap over the peninsula, does it wrap around the peninsula, right? How much actually goes over that ridge line and onto the east side? And then really conveniently that they put the mid-side elevation, the two mid-elevation stations at relatively the same elevation so that they can be compared, which is very clever. And so here's the first year of data. And when I explain it to you, you're gonna be like, yeah, no duh, Keith. It's not, I could have told you this, but right, most of it, a lot of fog at the low elevation, right? So by the tide pools, there's a lot of fog. And there's still a lot of fog at mid elevation and even a lot at the high elevation. So that western side's getting a lot of the fog. But what's interesting is you can see different pulses, right? So that low elevation one gets a lot through the fall into the winter, and maybe a little less in the spring. But in the spring, you can see that mid and upper elevation getting its a pulse. So we're starting to figure out like, okay, where are we getting the most fog, but like when and which areas? So that's important, right? Those details are really important. And then the Bayside, it's not really getting much, but you see a few pulses, right? Some in January, some in April, probably a couple really foggy days. So this is really important, right? You start doing this year after year after year, you start to get a sense of like how much fog we're getting, when are we getting it? Is it changing, right? Are you going to see these all of a sudden like different seasonalities in fog? And that's really important if the seasonality of fog changes, these plants respond to those sort of changes. And some can, but some can't. Some are going to bloom in April no matter what. And if April becomes a really dry month and we stop getting fog, maybe those plants aren't going to survive, right? Maybe that's not where we want to invest our resources. And maybe it helps us understand why we're seeing changes. So this is really important data, and I'm really excited to see this project continue on. Right. And again, it would help us, understand like the Pacific side versus the Bay side in terms of fog, what the input of fog is going to be on both those unique sides of the peninsula. But these aren't the only way to measure fog, right? This is the more traditional way. This has been out there for 10 or 15 years. These are called fog harps, right? So I can explain quickly, right? You see the stand and then you see the harp on top. And what that is, it's all fishing line, really, really densely strung fishing line. So when fog passes through those fishing lines, it condenses on the line and drains down into the metal gutter, which then spills it into a tipping bucket, which measures the amount of moisture, right? And then it's always paired with the weather station because if it rains, right, the rain will also fill that tipping bucket. So you're able to say like, okay, if the weather station has 20 inches of rain and the tipping bucket has 18 inches in there, we can say that we can contribute 2 inches to, or sorry, it'd be the other way around, 20 inches in the fog harp bucket and 18 on the rain gauge. Then we know 2 inches came from fog. So these have been put out in Channel Islands for many years. I think they have about 15 years of fog harp data. So they have their own method of monitoring fog. And so one of the projects I'm really interested in is adding these fog harps. And here there's a couple students from UC Santa Barbara that are building these fog harps, and they just deployed 6 of them on the Channel Islands. I'm getting them to build 4 more, 2 at Samo and then 2 at Cabrillo. And if we compare these with the existing fog stations at Cabrillo, you get 2 things out of it, right? You get a way to compare methodologies. Like, is one better than the other? Are they saying the same thing, or do they say something completely different? That will really help us understand like what we're measuring and how we might want to measure it differently. But it also would help create this regional network, right? You can start comparing fog at Channel Islands to fog at Cabrillo to fog at Santa Monica. And you can see like, okay, maybe it's changing at Cabrillo, but not at Channel Islands or vice versa, right? So you get this really kind of important regional contrast. Right. And so comparing these two is a very important methodology. So our last story of hope, and this is one of my favorite stories. I tell it in almost every talk, but it's such a good story for the partnerships and for the outcomes, right? It's a great story. So Shaw's Agave, Life on the Edge. Here's a picture of Shaw's Agave. This is in Baja California. You can see in the central image here, it's the orange blob is the California floristic province, right? Across that range, you get a lot of commonalities and species. A lot of chaparral, it basically covers that entire floristic province. At the very, very southern end in Baja California and a little smidgen into San Diego. And you can see here on the image on the far right, the range of Shaw's agave. You can see it's really prominent in the coastline of Baja California and just kind of goes over to the border into San Diego. And at the time, like the prominent plants, you go there, you see them when they're flowering, they're incredibly obvious, right? And beautiful and intriguing. And we had a botanist at the time, Adam Taylor, who was like, man, those things are just interesting. And he was a curious guy. And so he started digging into what can I find out about these? And at the time, there was virtually nothing published in science on the agave. There's a few like, kind of natural, in naturalist journalings of just like, oh, they're here and there, and I think they're this old, but I don't really know. No science, no published science, which is amazing. And so we were thinking about what could we do. We didn't really know anything. We couldn't find any data. And just fortuitously in the mail arrives this book here. You can see that in the image, the conservation plan for Shaw's agave. Like it was just really kind of it was fortuitous. It was really wild. And so it was everything that was known about Shaw's agave in this like 20-page booklet. We read through it. We were super excited. We contacted Sula Vanderplank, we did not know at the time, but was now a very, very good friend of many people in the park. And so we met with her and we went through this whole book and came up with this plan to kind of study the species. And the first thing we found out was that there were three populations in San Diego remaining. One at the border fields, which was obliterated when the border fence was expanded in, after 2000, September 11th, right? And then there's a population at Torrey Pines, which we know was planted. There's documentation. They took, I think, plants from the border fields and put them in Torrey Pines. So that left the Point Loma Peninsula as the only remaining population of the Shaw's agave in the U.S., right? It's still abundant south of the border. And in that was a really cool image of Shaw's agave from the late 1800s, what we think is like the intersection of Catalina Boulevard and Narragansett Avenue, right? So something in that sort of Point Loma-ish OB portal area, right? And so what this gave us information is like, look, these things have been here for a very long time. They're highly, highly, highly likely to be native to the area. I don't think the Native Americans were moving them from Baja into California to plant them in a garden, right? This is a natural, these ones in the Point Loma Peninsula are remnants of this original population of Shaw's agave. And we also found this interesting article from someone from the California Native Plant Society called Moving Day for Agave, right? And in that, there were a couple snippets of really important information. One, there were no agaves at Cabrillo National Monument. They were all on the Navy base in the Point Loma. And so they decided that, well, the Navy's protecting them, but it's not really their mission, right? They could decide to build a new structure over the agave population tomorrow, and there's nothing we can do about it. So they took 28 specimens from the base and planted them throughout the park. But what they didn't say is that they take them all from one clump, because they do clump, right? You can see the image in the bottom black and white image here. These single rosettes will put off clones of themselves and pup them, and we call them pups, right? They pup themselves over and over and over and create this massive clonal population. And did they take 28 clones and plant them in the park, which means we have one species, one individual really? Or were they smart and thought, we'll take one from here and one from there and one from there? We didn't know. It wasn't specified, right? So that's a big question. And so we put all these things together, worked with Sula, and we said, okay, well, what are our questions that we need to answer and that we can answer? And we came up with these four, right? So what's the status of Shaw's agave at Cabrillo National Monument? Are they producing viable seed? What's the genetic diversity of the population? And who could be pollinating the agaves? So question one, right? What's the status? This is where we said, all right, Adam, you're an ambitious young man. Like, here's a GPS unit. Here's some time. Go. Just go find everyone in the park and GPS them. So he went around and he identified every single individual and made all kinds of notes. Like, were they single individuals? Were they clones? How many clones? Were they flowering? Did they flower? So we had lots of this information, this spatial information about the species in the park. So that one was relatively easy, other than a lot of sweat and a little bit of blood from Adam. Two, are the agaves producing a viable seed? And honestly, this was kind of an easy one too. It's black and white, right? If their seeds are black, they're viable. If they're white, they're not. And so you can easily just go around, get all these fruits, crack them open, count the seeds. Like, hey, I have this many black. That's how many are viable. And so we did this at Cabrillo, and then we also did it on a couple trips down in Baja to compare, right? And what we found is 7% viability at Cabrillo and 20% viability in Baja. So almost three times as much viability in Baja. And that's, there could be a lot of reasons why that is. But sometimes when species are at the very edge of their range, even their natural range, they're slightly less viable, right? So maybe like it's not quite the exact habitat the species wants, but it's doable. And the result of that is maybe like, their seed viability is a little lower because it's not optimal. But that's enough, right? 7% would be enough. Question three, what's the genetic diversity of the population? This one is harder, right? And this is one where, like, when I talked about earlier, like, we don't have expertise in the park. Nobody in the park's a genetic ecologist. Nobody knows how to run genetics, right? So my job was to reach out and find somebody who would want to partner with the park. And we worked with the Boz Institute from UC San Diego, who came out, took samples from a bunch of individuals in the park. And then we're very lucky to continue to be working with Sula, who had samples from Baja California. So we're able to process all these samples at the same time and create this comparison between the population at Cabrillo and the population in Baja California. And this is the resulting phylogenetic tree of the data. And like, I still can barely understand it myself, right? But I can explain it to you using crayons. So you see all these pretty colors, right? So all the blue are navy, all the green are Cabrillo species or individuals. The kind of, let's see, the Rosarito is like another kind of shade of bluish green, and then Arroyo Hondo. So those are the two southern sites in Mexico. And what this is telling you is that when you'll see some clumped together, right? You see some green next to green, some yellow next to yellow, and so on and so forth. But if the population at Cabrillo were this sort of they had taken 28 individuals from one clump and they were all genetic individuals. You would have all those individuals on one line, all on top of each other, essentially, right? And even if they took maybe 14 and 14, you would still start to see clumping. You would see all the green in one area and maybe all the blue in another, and then all the red and orange in a different area. But you don't really see that, right? You see kind of a nice mix throughout both of these images. And what that means is that the structure of the population at Cabrillo and Navy Base is really similar to what we're finding in Baja California. And in this case, we're presuming the Baja California population is pretty darn healthy. It's still the most dominant species you'll see there. It's everywhere. It's undisturbed in many, many areas. So, we're presuming that that's the ideal state of a Shaw's agave population. And our population resembles that in its genetic structure. So that's really good news. That means like it's still a really wild natural population. So the last question, and maybe the most difficult, was who could be pollinating the agaves, right? So, kind of just looking at it, you see these tubular flowers, and they're almost always bat pollinated, right? And agaves are kind of known to be bat pollinated. And so we said, it's got to be a bat. And so we reached out to a local bat expert at the San Diego Natural History Museum. We said, it's probably the Mexican long-tongued bat. He said, look at the look at its distribution. It's all across Mexico and all throughout Baja and just above the border into the US. And that overlaps with the Shaw's agave uh, population, pretty strongly. So, he thought this is probably it. So let's go find this. Let's find this bat, right? And so the best way to do that is to set up these acoustic bat monitoring stations, right? You can miss net, you can sit out there at binos and try to see them, right? But to do it night after night after night is, a ton of work. So it's much easier to set up these detectors at various stations, let them run for a couple weeks, and then the stations pick up the calls from the bats. And each bat species has a very unique signature to their call. So you can kind of see the way that the frequency plays out. You say, oh, that's a pallid bat. Oh, and that one there is a brown bat. And they come in at different frequencies. So you look at certain bands for certain species and you can see them. So we set up this program with the Natural History Museum and Drew Stokes. And then so we have that going on, right? So that's like, okay, we're gonna do this for a year, figure it out. But at the same time, we figured, well, maybe we don't want to put all our eggs in that basket. What else could be pollinating the species? And so the Natural History Museum also had somebody just sort of sit there all day at the base of various agaves with binos and just see like what's visiting, what is coming out to investigate the plant. And it turns out it's mostly honeybees. Like 99% of the observations were honeybees. And we thought, well, maybe, right? Maybe honeybees, but it's not likely because the agave anthers only open up at night, which expose the nectar and all the pollen, and honeybees aren't active at night. So it's very unlikely it's a honeybee. And then we also set up camera traps, right? So maybe something's visiting at night when we're not out there looking in our binos, right? And it's not a bat, it's something else. We took 150,000 photos and we found one wood rat. So, we're just talking like maybe there's one wood rat's running around, climbing up, getting pollen on his chest and going to the next one, but it just doesn't seem really plausible that that one wood rat is responsible for pollinating our entire Shell's agave population. So, what did we learn from the long-term acoustic monitoring program? So, as of September 2023, we found 11 different species of bats, which is really amazing, right? There's 22 species of bats in San Diego County, and half of them are found at Cabrillo National Monument. That in and of itself is really amazing finding and really great work. But there was no Mexican long-tailed bat and no other known nectar feeding bats. So they're all insectivores that were visit the park. So it was a real bummer, right? And this is, we're going on year 6, year 7, right? Come on, it's got to happen. It's got to happen, right? But nothing, right? But then in October of 2023, we got it. We finally detected the Mexican long-tongued bat at Cabrillo National Monument. It was a single visit to the eastern side of the peninsula. So there's a set of agaves and a station we set up off the Bayside Trail. And so that's amazing, right? So we know the bat comes to the park. But even more interesting is that Drew also has detectors at the up in Escondido at the San Diego Zoo Wildlife Park. It was recorded at night there prior. And then, and Drew is plugged into this whole community of bat enthusiasts. And there's a guy who does this on his own. He sets up detectors at his house in La Mesa. And he found out about this. And he looked at his data and he found the bat 2 days earlier at his house. So we think the bats came up a few days from Mexico, kind of went through like La Mesa up to Escondido and made this big circle back, went by Cabrillo, and then probably back to Mexico. So really kind of cool story of community science, right, as well. So there's all these partnerships going on with the park and their partners, but then you're also working with these community scientists and to really tell the story of like, oh, so these things do happen. And what was really cool is that Drew said that there's only really been two documented cases of the bat even in Southern California, and they're from like 1950 and 1970. So it's really rare that they do it, but they do it, right? They do come around occasionally, and now we have proof that that's the case. So, right, so we have hope that maybe these agaves will get pollinated, and we don't know if if this individual visited and distributed pollen. We don't think anything did because that stand didn't have any active flowers on it, but it doesn't mean it didn't go to another stand in the park. It had flowers, so we don't know, and it would be difficult to figure that out. But just that we know that the native pollinator does still come by is a really important finding. And so just kind of wrap up that idea of what did we find out about agave at Cabrillo? We found there are lots of adults, but not a lot of recruitment going on. And there's some other side stories. If people have questions, I can tell you a little bit more about that as to why we think that is. Are the agaves producing viable seed? Yes, but it's lower than it is in Baja. The genetic diversity, well, it's comparable to healthy habitats in Baja, so we're very satisfied. And then who could be a pollinating the agaves? Well, we still can't say for sure, but we've got a really great lead, and we're really enthused to continue monitoring right into the future. And hopefully we see this species come back and visit us again. So that's what I have for you tonight. You'll see my website here. If you go to this website, find all kinds of cool stories about different things, including the agave. This is my email address. If you have any questions or want to connect, feel free to email me. I'm happy to talk more about it. And then happy to take some questions. Thanks, everyone.
Hey, thank you so much. That was an awesome multi-stories of hope tonight. That was great. Our bonus stories.
Hmm.
And just to add a little bit to what you were talking about with the bats, I know that there's been some recent endeavors for citizen science with people with their hummingbird feeders, because apparently some of these nectar feeding bats,
Hmm.
as they're migrating, will visit hummingbird feeders. So there are various different citizen science projects where you can set up a bat detector, either a motion censored camera, right, like infrared camera, or acoustic detector by your hummingbird feeder to see if perhaps that's it. So I wonder if maybe some of these bats have been visiting hummingbird feeders in San Diego County too, as they're making their way up,
Yep.
occasionally from Baja. So
Drew thinks
super
that
interesting.
Drew thinks that hummingbird feeders and then people planting a random agaves in their yard which have nectar, the bat doesn't have a need to fly all the way to Cabrillo anymore. It could just kind of cruise a neighborhood and find a hummingbird feeder or find, some other agave with nectar and just feed there. So it may be hard to detect it in the future just because there's so many other options to feed now.
Right. But with habitat loss, like maybe those options are kind of replacing some of the habitat that's
Yep.
lost, right? I mean,
Yep.
that would be an interesting study
Yep.
in and of itself, I think.
Yep.
See, everybody, you answer one question with science and then 10 more pop up.
Yep. That's the
And
problem.
when, or is it a problem? It's a beautiful problem to have. And we do have some questions. Speaking of questions
Great.
here in the Q&A, I'll go ahead and read these to you,
Sounds
Keith. So
good.
one is both a comment and a question from Mark Stevens. He says, great to see you after all these years. It seems like maybe there's a story
Yep.
here to tell. Thanks for the great work you're doing and the fascinating, encouraging presentation. And where are you physically based these days? Thanks again, Mark.
Hey Mark, yeah, good to hear from you as well, Mark. I'm still in San Diego. So yeah, when I took the position, I was fortunate to be able to be duty stationed here at Cabrillo. But I travel a lot, so I telework mostly, and because I'm on the road quite a bit, so splitting my time between the three parks. But yep, still in San Diego, happily.
Yeah, we're glad to have you there.
Hmm.
Um, Sandy wants to know if Samo is building a fireproof herbarium, and can Cabrillo send samples from our seed bank to it?
Good question. Yes, they are building a couple new structures. They're more fire resistant than the old structures. And yeah, that's a good idea. I bet they can do that. So I know there's some, I don't know if Patricia's on this or not, but I know there's a lot of collaboration between the three parks actually on seed collection in general. So yeah, having a central storage, right? We love Cabrillo, but we just don't have the space that Samo has and the capacity they have. So yeah, it's a really good idea. I can we can bring that up.
Yeah, I help with some genetic diversity too, if there's anything
Right.
that we're concerned about, right?
Hmm.
Um, Don Endicott, who is going to be a naturally speaking speaker for us in Peregrine Falcons here in February. There's my shameless plug. Is asking, are you aware of the Shah's agave at the San Diego Zoo Safari Park? And Don's been monitoring Mexican long-tongued bats adjacent to Shah's agave and other species there since 2023. So
Mm.
he's wondering if their agave might be genetically diverse, like Cabrillo's seems to be.
Good question, Don. I don't know about that population other than I assume it was planted, but from where I don't know. Um, yeah, that's a good question. We should probably ask them if they know, first of all, if the park knows anything about it. But yeah, good question.
Yeah, really good question. I have one of my own, if you
Yeah.
don't mind answering. I know we're a few minutes past the hour and I'm going to let people go, but I know for organisms that attach to rocks, removing them can actually damage their foot.
Mhm.
Um, and, you know, sometimes so much so that they can't reattach. So how do you remove black abalone from these
Mhm.
rocks to then transplant them somewhere else? Is there some sort of methodology, something you do for
It's
that?
a very gentle process, right? So you
Mm,
kind of they're always a little bit loose, but they have a good suction, right? But some of them will just if you grab them, they don't panic, sort of, and you can pry them off, and we take little plastic sheets under them, like kind of slowly like wedge this little piece of plastic under it, and then get them to stick to the plastic, and then take them back. But like if we grab them and they hunker down and they don't want to be moved, we don't move them. So,
yeah.
you got to go to an area where there's a couple thousand, right? And you just, oh, okay, this one's willing to go. All right, you're on a journey, my friend. All right.
Exactly. Listen to the animal, right? They're telling you
Yeah,
something. I
yeah.
love that. All right, and I think that answers everyone's questions. Thanks for hanging in with us for a few minutes. As you can tell, there's so many great conservation stories, and always like to end on a note of hope. You gave us many stories of hope, but Keith, is there something that people who are tuning in from home
Mhm.
can do that would contribute to conservation in their own communities or own neighborhood?
The what you brought up earlier, Sam, just if hummingbirds interest you or bats interest you, or like look around for something that interests you, right? And it might be setting up an acoustic detector for birds, for bats. You can contribute. That's incredibly valuable information. And I would just say find your passion for, yeah, for me, like my latest thing is like bird apps. Like I'm a terrible birder, but I can hold up a phone and look at it and be like, ooh, that's a such and such. Right now I'm learning bird calls. Or right now I'm learning more about the birds in my neighborhood even. So I was, something like that. There's such easy technology now that you can learn more about the world around you, even your neighborhood, right? In your back alleys and your backyards. And that's valuable information. So I'm a huge believer in community science. So I think that's where I would really encourage people to invest and love your national parks, of course.
Of course, and you can even do community science in your national parks.
Yes,
And I encourage you to
that's
check
right.
out Cabrillo's website for
Yeah.
some upcoming community science events that we'll be having here soon. So
Cool.
that's a great advice, Keith. And thank you very much for ending on that note and for everything you shared tonight. I want to thank all of you for coming. I want to thank the Cabrillo National Monument Foundation for sponsoring this talk. And I hope you tune in next month. We don't have a speaker set yet, but we will for January. And then in February, Don Endicott will be speaking on peregrine falcons and peregrine falcon monitoring at Cabrillo National Monument. Always a big hit. One of my favorite animals at the park. Well, thank you again, everyone. Thanks to Keith Lombardo, and we'll see you next time.
Thanks,
Bye,
everyone.
everyone.
Bye bye.